Good morning. Today we will discuss about range, variance, and standard deviation. After this presentation, you will know how to solve the range, variance, and standard deviation. Now let's go to our first topic, range. The range is the difference between the highest value and the lowest value in a data set. Range equals highest minus lowest. Basically, it is just the difference between the highest data and the lowest data. So you have here R equals H minus L. Example problem. Consider the following data set: 1, 10, 12, 15, 17 to 20. What is the range? First is, what is our highest data? Good, it's 20. How about our lowest data? 1, very good. Since you have our highest and lowest data, you can now solve for the range. Since the range is highest minus lowest. Our highest is 20, lowest is 1. 20 minus 1 is 19. So our range is 19. So that is how you solve for the range of the data set. Very good. Now let's proceed to the second. Variance. The variance is the average of the squared variation of the observations from their arithmetic mean, a finite population of size n with the arithmetic mean. We have two formulas for variance: population and for sample variance. This is their equations. So for the population variance, it is the summation of the quantity of score minus the population mean squared all over n, while the sample variance is the summation of the score minus the population mean and sample mean squared all over n minus 1. So the difference is, you have here is for the population mean and here is for the sample mean. And for the denominator, you have n, the number of data. If you have 10 as the number of data, you will substitute 10. While in here, you have n minus 1. So if the sample or the data is 10, so you will substitute 10 minus 1, so you will have an answer of 9. Let's have an example. A research recorded the following weights of chicken cordon bleu in grams from 10 restaurants in Busai. The data are as follows: 20, 21, 24, 19, 18, 25, 24, 15, 19, 16. Calculate the variance treating the data as population. So since our data is in population, we will use this equation. And we will substitute now our given data. So in here, 20, 21, 24, 16 is our given data. So all data will be substituted. So from the first data going to the last data. Now what is 20.1? Very good. It is our population mean. How did we get 20.1? Okay, that's great. You will just add all the data and divide it by 10. So you will have 20.1. And then you will write 20 minus 20.1, 21 minus 20.1 squared plus 24 minus 20.1 squared, all the data until to the last data, 16 minus 20.1 squared, all over 10. Use your calculator to solve for the numerator, or you may solve it manually. You have 104.9 all over 10, so that is 10.49. So our population variance is 10.49. Now you have already calculated the variance of this given data. This data is grams the weights of the chicken cordon bleu in grams from 10 restaurants in Busai. And this is the population variance. Very good. Now let's go to the second example. The CTE student recorded the following score: 69, 90, 75, 73, 95, 85, 82, 89, 79, 88. Calculate the variance with sample mean of 82.5. It is mentioned that it is sample mean, thus we are going to use this equation. We have the summation of score minus sample mean squared all over n minus 1. Now you can substitute directly the same of what we did in our first example, or you can use a tabulation. So for this second example, we will have a tabulation. So this is our tabulation. For the first column, as you can see, let's write down the data. So you have 69, 90, 75 going through our last number. Next is the score minus the mean. So the score 69 minus 82.5, which is our mean, is negative 13.5. 90 minus 82.5 is 7.5. And our last is 88 minus 82.5 is 5.5. So you will just do the same process here. Next is you will now square. Negative 13.5 squared is 182.25. 7.5 squared is 56.25. And the last one here is 55 squared is 30.25. So you will also do the same. So you square ni siya tanan. Okay, so for the last column, this one, is it possible for us to have a negative answer? Posible ba nga na ay negative diri? Okay, so in the last column, very good, all answers here are all positive because when negative multiplied by negative, it is positive. And same with positive times positive, it is positive. Okay, so we're done with this last column here. Now we are going to add this since we have here summation. So this is the sum, 632.5. So if you're going to add this, this is the answer. And this is already our numerator of this equation. So the numerator is 632.5 all over 9. Where did we get 9? Very good. 10 minus 1 because we have 10 data. So when you divide that one, you will have 70.28. Thus, the sample variance is 70.28. So that is variance. So this is how you solve variance. For the standard deviation shows how much variation or dispersion exists from the average, mean, or expected value. The same with variance, we also have two formulas for the population and sample. For the population, you have the square root of the summation of the quantity score minus the mean. This is the population mean squared all over n. And the square root of the summation of the score minus the sample mean squared all over n minus 1. So basically, the difference is the same. You have the population mean, the sample mean, and the denominator here is n, and here is n minus 1. The difference between standard deviation and variance is, in your standard deviation, you all have the square root already. Okay, let's have an example. Teacher Vall decided to analyze the variability of score using the concept of standard deviation. The score of the students are 987954. So what is our equation to be used? Is it sample or population? Okay, we are going to use the population since this is the only score that teacher Val wants to calculate its variability. Okay. So since this is our equation, we can now have this. We substitute all the data. You have the first score 9 minus 7. Where did we get 7? Very good. It is the mean of the given data squared plus 8 minus 7 squared plus 7 minus 7 squared plus 9 minus 7 squared plus a quantity of 5 minus 7 squared plus a quantity of 4 minus 7 squared all over 6. Okay, Miss, can we have the tabular form or for our solution? It's okay. So it's up to you, or it's up of the, you have to read the instruction. So you can have the tabulation, or you can have this. You directly substitute your given data to the equation. Now, we have here the numerator is 22. The square root of 22 over 6 is 1.91. Thus, we have the standard deviation of the given data set is 1.91. Okay, so what does it imply? In general, a relatively small value of standard deviation indicates that the value are closely clustered about the mean. So, it only means that if you have given data, if the standard deviation is small, relatively small, it only means that your data are more homogeneous, meaning kapare-pareha ra sila o score. While if relatively large value indicates the values are widely scattered or spread out about the mean. If dako ang imong standard deviation, your data are widely spread. Example, may kag 100, and then nakakag 1, 2, yan ay nasa 99. So, widely spread. More onto heterogeneous ang imuhang data. Okay, so we have here, we try to compare the formula of variance and standard deviation since you need to be familiar with its formula. For the population, as you can see, you have variance and standard deviation. Now, for the population, they have same equation, but for the variance, you have squared here, and for the standard deviation, you have square root here. The same with the sample. As you can see, they have same equation, except that your variance na siya square diri, while your standard deviation, you have the square root. What does this imply, or what is the relationship between variance and standard deviation? Okay, given the variance, so this is the variance, and you can see the variance na again na siya squared. So the variance, when you square root a variance, okay, when you square root a variance, we have already the standard deviation. Okay, so it only means that you can solve, or you can have the standard deviation without given data if the variance is given. So if the variance is 4, and when you square root 4, you have the answer 2. So the 2 here is your standard deviation. Okay, so that is the relationship. You have the variance, the square root of the variance is the standard deviation. Now, for your standard deviation, given the standard deviation, and when you square a standard deviation, you will have the variance. And that is, example, if you have 3 as your standard deviation, and you square it, so you will have 9. Thus, 9 is your variance. So that is the relationship between the two. When you square root a variance, that is standard deviation. And when you square a standard deviation, that is the variance. Now, let's have our summary. Summary measure of variation. We have the range, variance, and standard deviation. The range is R equals H minus L, highest minus lowest. The variance is the summation of score minus, we have here the population mean squared all over n, And we have here, it's sample, the summation of the score minus the sample mean squared all over n minus 1. Same with standard deviation, we also have two equations. This is for the population and this is for the sample. So you have the square root of the summation of the quantity of your score minus the population mean squared all over n, and the square root of the summation of the quantity of your score minus the mean sample squared all over n minus 1. So that is our summary, and now you know how to solve for the range, variance, and standard deviation of a given data set. Let's have our next topic. Thank you for listening.